We're going to be talking about how to make a fair test. This is a test where you investigate how one thing changing affects another thing. We use these all the time in real life. It helps us to determine if something is affecting another. To make a fair test, you have to look at two things, your variables and your errors. Essentially, first of all, your variables are things that can affect what you're measuring. And you have to make sure that you are only going to be changing one and keeping the rest the same, essentially. If you change more than one thing at a time, then you can't say that changing one thing definitely affected what you were measuring, because you changed more than one thing. So, first of all, you have to put a lot of thought into the variables that are going to affect your measurements in your test. The next thing is errors. We all know about errors. Errors are not mistakes. Errors are things that we've tried very hard to control, but we know are still going to be there no matter what. They can be human error. We're not perfect. They can be instrument error. There's lots of errors we're going to be going through in a little while. Now, here are the different variables that you're going to be asked to identify in your reports. Your independent, your dependent, and your control variables. The independent one, I'm about to show you, is what you control and change. This is the thing that you're saying, I think if I change this, that it's going to affect this other thing. And that's the thing you're testing. So it could be, I think if I drop something from a bigger height, it's going to cause a bigger splat. So essentially the thing that you're changing is how high you drop something from. Now on the other side of that is the splat. That's what you're measuring to see if changing the height affects it. We call that the dependent variable. So the dependent variable is what you measure to see if your changes have any effect whatsoever. Okay? They're going to be something that helps you to measure an effect. So it could be the amount of splat, which when you think about it is actually related to the force at which you hit. But we can't directly measure force, but we can certainly directly measure splat size. So the dependent variable is a measure to see if your changes have an effect. Now the last thing you need to do is think about the things you have to control. So when you think about the example of, if I drop something from a higher height, does it make a bigger splat? There are other things that can affect the size of the splat other than drop height. So if you pelt something instead of dropping it, that's going to affect how hard it hits. If you drop different size objects, of course they're going to have different splat sizes because they're different sizes to begin with. So you have to control a lot of variables to make sure that the only thing that's changing in this case is the drop height, and nothing else is going to affect my splat size. Okay? So the things that I would have to control in this example would be the mass, the size of the object I'm dropping, the way I drop, because if I splattered it, if I pelted it, it's going to affect the amount of force it hits with. There's a whole heap of variables that need to be controlled, because otherwise they're going to stuff up my measurements. Because then I can't say, yes, drop height definitely affects splat size, because someone else could say, oh, but you had different size things that you dropped there. It could have been that affected the splat size, not your drop height. So essentially these are the things that we need to keep the same or remove entirely to make sure that the test is fair. Okay? If you don't, they will affect your measurements and mean that you can't come to a definite conclusion about, in this case, does drop height affect splat size? If you don't control them, you can't answer that question. The last thing we're going to talk about is error today. These are things that are going to affect your measurements because they mean that they're not going to be as accurate or as precise because of the error that comes into them. And we're going to discuss a few that you can definitely fix up as you go. Number one is parallax. This is where you have someone's eye, any eye, and the thing is, when you look at something, you need to be looking at it at a straight angle if you're to get an accurate measurement. Doesn't matter what type of measure you're looking at, any type of scale or ruler, if you're looking at it from an angle, then you're not going to be getting a very accurate measurement. Okay, so parallax error means when you are taking a measurement, make sure your eye is at a straight perpendicular angle to whatever you're looking at to get an accurate measurement reading. Reading error is where you have a scale, but the problem is you have to make some little guesses in it, because whatever you're measuring actually comes to halfway along or partway along that scale, and you actually have to guess how much it actually is. So when it comes to this, the closest accuracy you really can get is halfway between the two units that are marked on your scale. So this one, say this is 3 and this is 4, the most accurate I can actually measure on this is actually 3.5, because my eye is not really able to make a very good estimation any better than half of whatever the units that I'm reading are. Next one here is instrument error. Instruments need to be calibrated, and if they are not, they will actually read wrong. So if you have an instrument and its reading is actually measuring wrong, it's not calibrated correctly, it's going to give you inaccurate measurements no matter what. So a lot of our scientific instruments, we have measures of, say, masses that we know are definitely correct. And we put them on our scales and stuff quite regularly to check that the scales are reading accurately and don't need to be calibrated or thrown out. Human reflex error is ones where you are doing the timing and it's actually your own physical ability to read a scale that's going to affect it. Think of a stopwatch. You're measuring a race. The person runs past it, then you click the stop button, then you look at the measurement of the time. There's going to be a slight difference between when you saw them and when your thumb actually went down on the stop of the timer. That's a reflex error, and we have to take that into account. The last thing here is a zero error. Anyone who's weighed scales knows that they don't always start on the 0. Sometimes your little arrow, it can read 0 below the 0 mark, or it can read 0 above the 0 mark, and if that's the case, it's not starting in the right place to make a measurement at all. So zero error means that you make sure that your scale is set perfectly to 0 before you measure whatever it is you're putting onto it. In the case of a ruler, that means that when you're actually measuring something, you place them at the 0 part of your ruler. You don't start them somewhere along here and measure where they come to. You make sure that they are starting at the 0 part of your ruler. Now you have to go back into the video and copy out the following definitions. The definitions for independent, dependent and controlled variables, and this page here which shows us all the different types of errors and their definitions. Thank you.